All right, the second part of 2.1 is still solving, but we're solving inequalities. So what you'll notice is that instead of having an equal to sign, we have a greater than or equal to, a less than, or a less than or equal to sign. So this one has already been isolated, where we're saying x is any number equal to or less than -4. But if we do not have it isolated, we can isolate that um, x value. So we get 2x is greater than 11. We divide both sides by 2. So we get x is a number greater than 11 over 2. One thing that's really, really important to remember is that if we ever multiply or divide by a negative, we have to change the direction of the inequality. This is very, very important. So let's look at our first example. We want to isolate our variable. So we have negative 11y. I can bring my 9 over by adding. So we do not change the direction of the inequality because we are adding. 13 plus 9 is 22. Then we divide by that negative 11. So because we're dividing by a negative, the direction of the inequality changes. We'll cancel our negative 11, so we have y, and we'll simplify the right-hand side, and we get -2. If we're going to put this on a number line, because it's less than, we have an open circle. We would close that circle and shade it in if it had an equal to sign, and we're saying that y are values that are smaller than -2. So our arrow is going to go to the left. First thing we want to do is distribute the right-hand side, so 10x minus 12, and we can keep the left-hand side. Then we want to collect like terms. It doesn't matter which direction you put the x's or the y's. So -7x, and I'm choosing this way just to keep my x's positive. So I get 3x on the right-hand side. If I add 12 to both sides, I get 9 plus 12, so that gives me 21. I divide by 3. I do not change the direction of the inequality because we're not dividing by a negative. So x is a number smaller than 7 and including 7. So I'm going to put 7 and I'm going to put my line to the left. We can have something called a compound inequality, where it means that we just have two simple inequalities that are joined together. There's two different types. One is called an and one is called an or. So the first one we're going to look at is an and. So here's my simple inequality. It says x is greater than 2. So I have my 2 here, and I'm saying it's all numbers greater than 2. And then if I put my other simple inequality there, I'm saying x is less than 7. Now, to actually finish this question, we're saying where do both of these inequalities overlap? So what are the answers that are one and the other? So we're saying where do the lines overlap? Well, they overlap, between 2 and 7. So our final solution are all numbers between 2 and 7. So if we read this, we say x is greater than 2 and x is less than 7. So our final solution is taking those two simple inequalities and answering the question, where do they overlap? So where is our final answer is where one as well as the other inequality exist. An or is the case where we have our inequalities going in separate directions. So it looks like this. We cannot change the answer. We can't write it together. It must be separated because they are two separate lines. So that actually is our final answer. Where this gets a little bit complicated is we have these special cases. And you are going to need to know these very well. So the first one I'll show you is the simple inequality of x is less than 2. So that's my green line. And x is greater than 4. Now, this specifically is an and in between it. So it's asking the question, where do the two lines overlap? And they don't overlap. So we would say that there's no solution. Because again, this is an and. Where do they overlap? And they do not. Let's look at the next question. X is greater than 2. So what's really important is you need to see a visual to answer these questions. And the other one is x is less than 6. So this is an or. So instead of answering the question, where do they overlap, we're just saying which numbers are part of the solution at all. So this arrow is saying everything from 2 greater than to positive infinity. And the other arrow is saying everything which is less than to negative infinity. So this is actually infinite solutions because every single number is being covered by one of those arrows. The next one, x is greater than 2. And these all work for equal, greater than or equal to as well. And x is greater than 4. So because it's an or, our final answer are any possible numbers that are being covered. So x is greater than negative 4 is our final solution. The difference between this one and the next one, x is greater than 2 and x is greater than 4, is because it says and, we're looking for where are the two lines overlapping. And the two lines are only overlapping from 4 on. So x is greater than 4 is the final solution. So in the third example here, the difference is it says or, so it's every single number which is part of our solution. And in number 4, it's only where the two lines are overlapping. So let's look at a question here. Notice that we're given an or, so we're first going to simplify each side. I subtract 4x, so I get x, and I bring the negative 3 over, so I get x is greater than negative 3. I put that on my number line. On the right-hand side, I'm going to distribute, and then I'm going to collect like terms. So I get x is less than, this is equal to 5, so I bring it to the right-hand side, and x is less than negative 5. It's an or, so I'd expect it to be two lines going in opposite directions, which it is. So that means that my final solutions are okay. It's not one of those special cases. So I'm going to box my answer. Now this question is an and. So I'm going to simplify both. So 2x minus 10 is greater than or equal to 2. I'm going to collect like terms, so I get 2x is greater than or equal to 12 by adding 10 to each side. I divide by 2, so x is greater than or equal to 6. I'm going to put that on my number line. Because it's equal to, I shade it in. Then we have an and, so I'm looking for where are they overlapping. Let me simplify the right-hand side. I collect like terms. So I end up getting 3x, and then I will simplify. So I get x is greater than 8/3, which is about 2.67. So I'm going to put an open circle here, and then my line to the right. Now because this is an and, I'm saying where do these two lines overlap? Well, they only overlap from 6 on. So that is my final answer. This is a different way of looking at an and question. What we want to do is we want to separate it into two different inequalities. So we use that expression in the middle in both of them. And this is separating into an and, as I said. So I simplify the left-hand side. I'm going to bring my 2x over to make it positive. I'm going to add 5 to both sides. So I get 12, and x is less than or equal to 6. I'm going to put that on my number line. I like to do this right away so I don't forget. One of the common mistakes I see a lot is people just giving me the answers and not putting it on the number line. And the number line's really important because it helps you identify those special cases. So, oh, actually, I'm just going to bring it to the other side to make it positive because I like working with positives better. So 2x by adding that to both sides, and then when I subtract 9, I get negative 2. So x is greater than or equal to negative 1. And because this is an and it doesn't say that in the question, but just the way the question is written, that's implied an and. So I'm saying, what is the final answer? Well, it's where they overlap. So it's between negative 1 and equal to and 6.